Many times, young civil engineers are very new to alternate technology, and in this vlog, we'll introduce you to a simple and excellent alternate system. Hi, I am Premjit, structural consultant and founder of civilera.com. I'm happy to be here with our new vlog. So let's discuss an alternate slab system, void slabs. What are filler slabs? Filler slab is supposed to be a cost-effective, efficient, simple and very innovative construction technology for slab construction. Now it is very efficient if it is effectively designed and constructed, so that's very important. That's what we are going to discuss. Now, as the name suggests, in a filler slab, part of concrete in the bottom of the slab in the tension zone, to be specific, is replaced by a filler material. So that's what you can see here in these figures. So if you see here, you don't have concrete in the tension zone. So that's what we effectively do. So to be very clear, you are having rebars here along the ribs, and then you are replacing the concrete here by placing a tile or a filler material in the formwork. So that's how you achieve this particular structure. So I'll be explaining this in a bit detail in the subsequent time. Before getting into the design in detail, let us just see what are the conventional approaches. So conventionally, we have been using mangrove tiles, clay pots as fillers, many clay substances as fillers, broken pieces of cement blocks, coconut shells, glass bottles are also sometimes used. These are all conventionally used in villages to towns to cities. So whoever are into alternate slab system have been using all this. Very recently I have seen an architect using damaged computer keyboards as a filler material in a media room. So all these innovation and changes and experiments do happen, and you can use various filler materials like this. Any cyber waste can be used as long as it is aesthetically pleasing. Sometimes clients choose filler purely for aesthetic reasons and don't care for local availability. Otherwise, the filler materials used are generally less costly because we adopt the locally available material. The reason for the cost effectiveness is due to the use of local materials, as I just mentioned, in combination with the reduced use of concrete. At one point in time, filler slabs were really economical. Now we cannot always say it is economical until and unless you choose locally available material, you have the skilled manpower, all that. As compared to reinforcement concrete slabs, filler slabs consume less concrete and steel if it is rightly designed and executed. So surely this is greener based on what filler you choose. You are consuming less steel and concrete, so that is a big advantage. Now, what is the structural fundamental of using filler? I just briefly explain now. As we all know, for simply supported RCC slab or any flexural member for that matter, lower part of your neutral axis experiences tensile forces. So I have explained this in another blog, so you can read that in civilera.com/blog. I'll be cross-linking it here in any way. If you have a simply supported beam or slab, you are going to have a bending moment something like this. So this is going to be WL squared by 8. If I draw the beam as such or slab as such, it's more likely to be like this, and you know that this is your tension zone and this is your compression zone. So if I assume that the neutral axis is somewhere here, then you know that your tension zone is this and your rebars are going to take your tension. You don't need any concrete in the tensile region. So this principle is what is adopted in this alternative system. Now, concrete being a fluid, we don't have a mechanism to remove the concrete from site during construction because it's a fluid. You cannot remove it from where you don't want that. So you need a means to remove this concrete from the formwork. So that's what you do by filler. So I will explain it more carefully. So if you have a slab like this, so something like this, say you have rebars laid out in some spacing, say something like 300, and say you have the rebar in the other direction, something like this. So let us assume that you have a 300 by 300 spacing rebars all across the slab. So now the technology is nothing but you are going to have a tile or a substance kept here inside this. Now when you do this, what you need to ensure is that you have proper cover to the rebar. So if you don't have proper cover to the rebar, then you will have all the problems. So we will have to achieve proper cover. So if something like this is done, then this is what you have. So this line and this line forms a band of concrete where your rebars are embedded. The same way in the other direction also you will have the same. So you will see a band in both directions. So this is the basic principle. So you don't need your concrete in the tension zone. So in the bottom region you are removing as much concrete as possible by doing this. So this can be a cover and this can be a cover required so that you ensure your rebars are protected from moisture and other corrosive agents. So the rest of the tensile area you are placing a brick or a block or a tile, whatever it is suitable as a filler material, so that you are able to remove the concrete from the tensile zone. In tensile zone your concrete is not at all required. So that's the design principle. So if you look at this figure, it is very clear. You can see that you have a rebar and you have a filler material here. So if you are pouring concrete on top of this, you will see that band. So this is what is being done in this particular alternate system. Now you can see after concreting, this will look something like this, and you can see another filler slab here. So there are a variety of ways that you need to deal this in terms of design, but most of it is very simple when it is a very normal slab. Please note that we will need adequate cover to the rebar and stringent quality control during the design and construction stage to ensure proper binding of bars, holding of bars, thereby ensuring strength, serviceability and durability. Now, let us briefly discuss history of filler slabs in India. Filler slab technology has been used across India from a long time in different forms. The main architect of this alternative construction method is an architect called Laurie Baker. So you can see him here. You can Google and find out more about him. He is a revolutionary architect who made filler slab and alternative technology very popular in India, and especially in Kerala and south of India. So there was a period in the history of Kerala where everyone wanted Baker model homes. If you Google, you will get Baker model homes, and you can see and you can enjoy the beauty of his architecture. So in 1960s, even at that time, he was using green concepts in architecture, and he is regarded as Gandhiji of Indian architecture. He was an outstanding architect in sustainable architecture and green buildings, incorporating these design principles as early as 1960s. Concepts of rainwater harvesting, minimizing usage of cement, all these were included in his methods. Now let us quickly discuss some selection criteria of filler materials and some of the generally used filler materials. Filler materials should be non-reactive to cement and water. So that's very much required. Otherwise you will have corrosion issues. The filler dimension, size and shape have to suit with the reinforcement spacing. This shall be well coordinated between all stakeholders like client, architect and structural engineer. What I mean to say is, you need to have proper binding for the rebar. So that space should be available like a band. Only the remaining part you can have a filler. So that needs to be really understood. It's mandatory to ensure the water absorbed by the filler is minimal. Otherwise you will have construction issues and design issues, and later you will have a lot of additional issues, corrosion and various things. Local materials to be chosen to keep the costs in control, and lightweight materials to be preferred that will reduce the weight of the entire slab. Ceiling patterns and the functional use of the room also decides the material selection. So if the client wants a really pleasant ceiling, then you might choose some particular filler material. For example, we cannot propose a computer keyboard in a dining room because it is not related to that functional use. However, a keyboard as a filler is perfectly suiting a media room. So that's how you need to plan. Anyway, that's an architect's role. But then I was just making a point on that. Now, filler materials generally used are mangrove tiles, clay pans, bricks, then waste bottles sometimes, coconut shells, thermocol, cyber waste like keyboard, stabilized mud blocks, and terracotta tiles. So you can choose from a variety of things that we are already using. Now, some of the planning and concreting at site related aspects. So here, filler slabs are normal slabs cast in site. Now, formwork is laid. I already sketched and showed you. And then the rebars that are designed are laid. Generally, a maximum allowable spacing of 3D or 300 is adopted because that's what your code allows you to do. Minimum needed steel is also needed to be provided. That's 0.12%. And if a better quality control can be provided, and if crack widths can be checked by design, we can adopt wider spacing than 3D or 300. So that's an important point. Sometimes if you want more than 300, you know that as per the code provisions, the maximum allowable spacing for main reinforcement in a slab is 3D or 300. You can refer IS 456, the relevant code clause. I am not straight away remembering, but that's there in the code. I think it is in 26.3.3 of the code. You can check. If not, you will have to refer the entire code on the maximum allowable spacing. You can get back to me if you fail to do that. But in my memory, it is in 26.3.3. And there is also a clause which says that if you are checking the crack width as per the annex in IS 456, then you can have a wider spacing than what is mentioned in the clause. So 3D or 300 need not be adhered to if you are checking the crack width and ensuring that it's within 0.3 millimeter. So if you are able to do that, you can go for a wider spacing. So the crack width calculation is also there in IS 456 in the annex. And also note that the filler material is something that absorbs water in most cases, and it should be soaked in water to ensure that during construction it doesn't absorb water. So that's all very important. And if you stick to the design and the construction good practices, then you will have a very good filler slab executed, and that will be a really good home to live in. If you are listening to my video in YouTube, I really recommend you to go to my blog www.civilera.com/blog and read that as well, because that has some more information than what I am speaking here. So I recommend doing that. Now let's discuss some advantages of filler slabs. Now, due to the replacement of non-functional cement concrete with lighter filler materials, as I told from the tension zone, dead load of the slab is reduced considerably. And this helps in reducing the foundation size, steel required in structural members. The reduction in weight as much as 20 to 30% can be done if you are doing it in a right manner. Many fail to note a very important point, that reduction of dead weight has a very compounding positive effect. So we think that, okay, I reduce the slab thickness, so the forces are less, the steel is going to be less. Yes, but one more thing is that your seismic demand of the building, if it's a 3-floor building or a 4-floor building, the seismic demand is going to come down. If you remember, or if you know, earthquake is nothing but an inertial force. So when the ground is moving, and if you have a building on your ground, and when the ground is moving, then it's experiencing an inertia because of the sudden movement. It's similar to something like when you are in a bus, and when the bus takes off, and if there are people standing on the bus holding somewhere, and when the bus takes off, if they are not holding, they are going to fall down because you are being pulled down to the earth's center, and you are suddenly having a movement, a horizontal movement, and that's what's called inertia. And that's the same thing that happens when an earthquake strikes. So it's ground movement, and that ground movement is converted as a deflection kind of load because of the inertia. So if you know that in a bus, when two people are traveling, one with a heavier mass and one with a lighter mass, say 100 kg person and 60 kg person, you obviously know that the person with more weight is likely to feel more inertia, and he's likely to fall down, or he's likely to sprain his hands or joints. So the same way, when your mass is more in a building, your seismic demand is going to be more. You are required to make it perfect, or you are required to make it earthquake resistant by providing that much more attention to that. So your seismic demand comes down when your weight of the building is less. So a filler slab helps you in doing that to a certain extent, and it is cost effective at least by 20% compared to the conventional RCC slab due to the usage of less costly filler materials. Again, as I said, you have to use the right materials and the right design, and it doesn't compromise the strength or durability if you are using the right construction methods with good quality control. Filler slabs do create comfortable temperature conditions inside the living room, as the air pockets between the filler materials has heat resistant property. The thermal comfort provided by filler slabs make it an excellent option in humid, hot climatic conditions. So that's something which we need to understand. When materials like cyber waste, like keyboards, waste, plastic substances, especially bottles, are used as fillers, this method by default does a waste management for you. So that's another point that you need to consider if you are adopting this. It's a positive point. It reduces the carbon footprint. Correctly chosen patterns in the filler slab increases the aesthetics of the ceiling. Now, there are some disadvantages if you don't execute this very clearly and correctly. The filler slab technology needs some experience. Unless we have people who have built a few similar homes, there are chances that you mess up in its construction. The rebars can corrode if it comes in contact with clay products that are used as fillers. So these are all things that you need to take attention. For the same reason above, the slopes at the terrace have to be meticulously planned, and the rainwater downpipes has to be clog free. So these are all very important points. Enough care to be taken to ensure maintenance of terrace so that there is no water stagnation. So analysis and design of filler slab, we will quickly mention that there is no need to have much difference in load calculation, distribution, analysis, and structural design of filler slabs used in short spans from a normal slab. The load calculations have to be accurate to take benefit of the lesser weight. If you don't make use of the lesser weight's benefit, then you may over design that. Even live loads has to be refined. I have another blog. I will link it up in the blog. So please read the blog. There will be a link to the other blog which tells you how to refine your live load. If you know what is live load recommended by the code IS 875 part 3, you calculate and see the real live load coming in a building is much lesser than the one given in the code. But I'm not saying to compromise that, but then there are ways that you can fine tune it and use the right amount that is needed in a building. So based on all this, you can economize it, and if the slab is one way or two way, you decide based on the span ratios as in a conventional slab, and then design it as one way or two way based on the ratio, and then based on the edge condition you can take the moments from the table in IS 456. So I'm not explaining that because it's very much similar to what you have for a normal solid slab, especially when your spans are less and when your filler material is not very wide. Now sometimes you have very wide filler material, sometimes you have waffle slabs. In such cases, or when you have a ribbed floor where your spans are higher and where your filler material or your voids are larger, then you may want to take the T-beam action, and then the ribs will be much deeper and you can design that as a T-beam. But I'm not getting into it. I'm considering only a normal filler slab that we generally use in homes for aesthetics and thermal comfort. So let's limit our discussion in this vlog to a normal void slab. So in such slabs, there are no additional design points needed to be considered, except that if you're considering it as a simply supported system, then your slab thickness can be a little larger because you are not considering the continuity. So I would recommend that in a continuous slab system, you can avoid having a filler material very close to the support. So what I mean to say is your bending moment diagram will not be like this if the slab is continuous. So if your slab is continuous and if it has multiple spans, then your bending moment diagram will be slightly different. It will be something like this, and you will have negative moment here. So if you release this moment and take everything here, there are chances of crack formation here if it exceeds the capacity of the rebars. But then generally it won't happen because we have a factor of safety. So if you want to understand about this redistribution, please read another blog. So I will again link it up there. So if you are doing this, what I recommend is don't release that moment. You can probably consider a band here and avoid having your filler very close to the support. You can provide additional top steel for ensuring its capacity there, because the tension is at the top because of the hogging. So that's one additional point that you may want to consider. Everything else remains same as in a normal solids. You can satisfy the deflection based on the L/D ratios. So let me conclude by thanking you for watching this video and reading the blog. I hope this has been useful to you, and in case if you have any questions, please comment or get back to me by email, or you can go to the forum section in Civilera and then ask me questions there. So thank you for watching. I hope you enjoyed, and please like and share this blog if you have liked the content.